So, welcome to JEE Crackers. So, today in the previous lecture I have completed parabola. I guess that you have learned something about the basic, what I can do about the parabola, what are the basic things you need to understand. I have targeted to provide you in lucid style, but I may have still some limitations. I would like to ask you for my betterment. You can go and write in comment section also. So let's start today ellipse. Ellipse is the next part after parabola. Uh, so as you know, uh, just writing, it is another part of conic section, right? So the basic thing about ellipse is, suppose a fixed line is there, the same way I will discuss what I have discussed in parabola, right? So fixed line, suppose there a variable point P is there and a focus S is there. Whenever we are discussing about any, you can say, a conic section, we are discussing in the same manner. You are having a variable point P, that is also called a moving point, and a focus, which is a fixed point, right? And the fixed line, which is also termed as directrix. So if we draw a perpendicular PM, suppose, and if we join PS, if SP over PM equals to constant, equals to E. Suppose this E, the eccentricity value, this is the eccentricity. If the eccentricity is less than 1, suppose, if the eccentricity is less than 1, then it is ellipse. Then you can say the path followed by the moving point or the locus of P is a ellipse. It's a basic thing. For parabola it is 1. So for ellipse you will have two focus. Suppose this is a ellipse I am drawing. You will have two focus, and suppose a point P lies on the ellipse. Suppose these two focus are F1 and F2. Let us say if we join PF1 and PF2, if PF1, if we add that value, that is if PF1 plus PF2 is constant, that is P is moving in such a way this condition is satisfied, then we will say the locus of P is a ellipse. This is another way to describe, and this value is equals to length of major axis of ellipse, major axis of ellipse. So I think some basic idea I have provided. So if we draw ellipse like that, let us start with the standard equation of the ellipse. Okay, if we draw an ellipse such that these are the two axes, the larger axis length is the majority axis and the smaller axis length is the minority axis. Clear? And suppose these two are the focus and we are drawing a line which is perpendicular, then it will be termed as latus rectum. I have to write general standard equation. Okay, for general standard equation, the equation is x square over y square plus y square over b square equals to 1. This is the general standard equation, where b square is also termed as in the form as a square. As b is the minority, 2b is the this length, right? And 2a is the majority axis length. As we know that b is less than a, therefore e less than 1. Clear? So let us start go in another page. It will help you to understand in better way. So let us draw ellipse. Okay, suppose this is the ellipse, this is the axis, these are the latus rectum, and we know that we will have two directrix on this side and on this side also, two directrix. So if I name them, suppose this is f1 f2, clear, and this is suppose l dash l1 l1 dash, then I can say, suppose you are having two endpoints, this is a and this is a dash, suppose, then I can write a dash are vertices, right? f1 f2 focus, l dash l1 l1 dash latus rectum. This f1 f2 is equivalent to plus minus ae comma 0. That is, if this is f2 is ae comma 0, then this, if we put it on the equation of ellipse, then latus rectum will come in the form of ae b square over a l dash ae minus b square over a, in this manner. That is, if I need to write what is the length of the latus rectum, length of the latus rectum, we can write l dash means 2b square over a. Clear? This length l dash or l1 dash. Clear? And I've told you about the majority axis and the minority axis, and the condition is that a greater than b. 2a is the length of 2a, that is this length is the 2a length of majority axis, length of major axis, right? And 2b is the length of minor axis. Clear? And the distance between two vertex a dash is 2a. You can say distance between two vertex is also 2a, and the length of minority axis is 2b, right? Suppose if any point p is there, if we add pf1 plus pf2, this will be focal, then these two distance are focal distances, right? As there are two focus is there, then this is the focal distance. Suppose a chord is passing through the center, suppose a chord is passing through the center like this, if the chord is passing through the center, then that chord is known as diameter of the ellipse. Suppose this is C, this is C, this is D, then CD is the diameter of the ellipse. Can you see it? I know, if you want to see, can you see? Yeah. This is the diameter, and if we draw a perpendicular from that P then towards F2, then that will be double ordinate. I will be discussing in the later part, right? So if the condition is opposite, that is B greater than A, the ellipse will be like it will be like this, where E will be, eccentricity value will be 1 minus a square over b square, as a greater than b. Sorry, 1 plus a square over b square. Is it clear? So, oh, sorry, 1 minus, I have told something, 1 minus a square over b square. So here the center is same, 0 0. This is the center, this is the center, 0 0, but vertex will be this vertex, that is 0 comma plus minus v. If I want to say the focus, it will lie on y axis, then foci will be 0 comma plus minus v. If I want to say about the latus rectum, then it will be 2a square over b. Equation of the directrices, I have not told here, these are the two directrix, and this equation of the directrices are, this will be as y is negative minus b over e, and this will be y equals to plus b over e, sorry, a over e. Here it will be a over e, because a is the major axis and here b is the major axis, so you can say it will be the directrix will lie here and here, two directrix, and the equation of the directrix will just change into y equals to plus minus b over e. Clear? And if I need to say about the length, here the length of major axis is 2b. Clear? Length of major axis here is 2b. Clear? So I think it is very clear. It is so easy, you need to stand by clearly, right? Let's go to the new part of the ellipse. Okay, I hope it will help you to learn better. Suppose the center of the ellipse is not origin, this is center not origin. Suppose the center is lying at hk, let us say this is the ellipse and this center is hk, then how will the equation change? Then the equation will transform in this manner. Just instead of x, it will be x minus h over a square. Instead of y, it will be y minus k over b square, and this will be 1. That is, this can be written as x square over a square plus capital Y square over b square equals to 1. We can write. So here the center is capital X equals to 0, y equals to 0, implies small x equals to h, y equals to k. For focus, for vertices, for 0 0, what is the vertices? A comma 0, If it is hk, then vertices will be just add h over a and 0 plus k. Clear? For foci, if the center is origin, then foci is plus minus a0. We know that. If center is hk, then just add h in x coordinate and add k in y coordinate. This is the methods. Clear? An equation of directrix. I am just want to show the similarity, right? If we learn the similarity, then it will be much more easier to learn if the center is h comma minus k, or if the center is minus h comma k. It would be much easier for you. I will not discuss much about that because this very part will give you the best explanation of all those, right? So the equation of directrix will be, for the center 0 0, it will be x equals to plus minus a over e for center 0 0. If the center is hk, then just add h, right? And the length of lattice rectum will not change, it will remain same. Only length of lattice rectum will remain same. It will be same 2b square over a. Nothing to change, right? I think it is clear to you. So the next part of ellipse, I feel that you need to go through some important part about the how to write the parametric equation of the ellipse. I have discussed in parabola also about the parametric equation, right? Now I am going to discover some important things about how to get the parametric equation of the ellipse. For that, we need to have a circle. That circle we need to have, and that circle is popularly known as auxiliary circle. I will be discussing in the next note. It would clear you more. That is, I need to have a fictitious circle. Okay, so suppose this is the ellipse. I need to have a circle having major axis as a diameter. That circle will be called as auxiliary circle, right? I am writing the name auxiliary circle. What is auxiliary circle actually? A circle drawn with length of the major axis as diameter. That is length of major axis as diameter. Clear? So if the equation of the circle is, suppose x square over square equal to a, then we know that its parametric equation is a cos theta a sin theta. You know, suppose a point P is lying over the circle, okay, and we are just doing perpendicular, and in the, suppose this is so suppose this is P and this is Q. This is the auxiliary circle, right? And suppose the any point lying on the ellipse is P, and the perpendicular distance, suppose this is M. If we join from the center, this, suppose this is C and this is A and this is vertex A dash, then we can the Q can be written in the form of a cos theta a sin theta. That is x coordinate Cm equals to a cos theta, and Qm equals to a sin theta. Equation of the ellipse is x square over a square plus y square over b square equals to 1. If Cm is a cos theta, please clear it. Okay, if Cm equals to a cos theta, then the x coordinate of P will be same. X coordinate of P will be also same, that is a cos theta. And suppose I don't know the y coordinate. To get the y coordinate, we put that a cos theta in that equation, and if we put the a cos theta here, just you will get y equals to b sin theta. Then you can write y b sin theta. Clear? And in some cases you may find that it is written in the form of e to the power I theta plus e to the power minus I theta over 2, and sin theta also written in the form e to the power I theta minus e to the power minus I theta over 2i. In this form also it is written. Okay, nothing to get scared about that equation. Okay, so this equation is the parametric equation of ellipse, a cos theta and b sin theta. This theta, suppose this is the theta, actually I have not written this is the theta, and this theta is known as eccentric angle. Note it, angle ACQ is theta, not angle ACP. Q is lying on the auxiliary circle. We are taking the help of circle, otherwise we can't go further, right? So in the next part we are going to discuss equation of chord. So I will just write the equation, and while doing hyperbola I will provide you the similarity of that equation. Okay, that will be much more easier for you to learn. Suppose this is the ellipse. If you need to obtain the equation of the chord of contact, equation of chord of contact, equation of chord, then suppose the extremities are a cos theta, b sin theta in parametric form, and this is suppose a cos phi, b sin phi. Then if the equation is x square over y square plus y square over b square equals to 1, equation of the ellipse, then you are going to get y, just if I write in normal point form, it will be like this, y minus b sin theta equals to b sin phi minus b sin theta over a cos phi minus a cos theta into x minus a cos theta. This, if we simplify this part, this and this part, you are going to get a final form in this manner. Right, x by a cos phi plus theta over 2 plus y by b sin theta plus phi over 2 equals to cos theta minus phi over 2. Clear? This is the equation of chord. Is it clear? This is very easy part. Let's go to the new part for discussing some other concepts also. Now, what will be the position of a point with respect to ellipse? Position of a point with respect to ellipse. To get that, suppose the equation of ellipse is this, and if the equation of ellipse is suppose x square over y square plus y square over b square equals to 1. And if let us consider p x1 y1 point is given, and we need to see whether p lies on the ellipse or whether p lies inside the ellipse or outside the ellipse. If we put that value here, that is x1 square over y square plus y1 square over b square minus 1, if this value is greater than 0, then p lies outside the ellipse, right? If this value is less than 0, then definitely it will lie inside the ellipse. And if this value is 0, that means it is satisfying the ellipse equation, that is, it is lying on the ellipse. I have told about parabola, just the same case here. Nothing, there is no difference actually. If we learn parabola, you are going to get the concepts very clear, very easily for ellipse. Let us start with the ellipse and line. I have discussed about parabola and line in the previous lecture actually. You are supposed to do the discriminant part greater than 0, less than 0 and equals to 0. If it is equals to 0, then we are getting a single point, and that will be that condition for the tangent. So let us consider the equation of the ellipse is this. If the equation of the ellipse is this, and let us consider a line which is written in the form of slope form is y equals to mx plus c. We just need to see whether it what will be the condition so that the line becomes the secant, or line lies outside, or line is the tangent. So we need to put the value of y here, and if we put the value of y, then we are going to get a big equation, and the big equation I think will look like this. If we further simplify it, you are going to get this. It will a quadratic equation in x will come, and it will be like this, right? This quadratic equation we will get three probabilities of discriminant, that is d equals to 0, less than 0 and the greater than 0. And if we find the value of d discriminant, that is b square minus 4ac, we are going to get a simplest form. I am just writing 2a square mc whole square minus 4a square m square plus b square a square c square minus b square. If we simplify this part, you are going to get like this, m square, just like this. Discriminant value is like this. If discriminant value is less than 0, then you must you know that a single point same roots, and for that you are getting a single point, and for that the intersection of line and ellipse is a single point, and that is the tangent. That will help to understand about the tangent. The implies the tangent, and for that tangent d equals to 0 means a square m square minus c square plus b square equals to 0, or c equals to root a square m square plus b square. Clear? I think it is very easy actually, huh? Okay, and it will be a plus minus actually, right? So the equation in slope form, the tangent equation will be just like this. In place of c, we are writing this part, okay, in the form of ab. Clear? So if d is greater than 0, if the d is greater than 0, then you know that we will get two real roots. If you are getting two real roots, then that line will just become the, you can say, the secant, just like this. Suppose second, two, we are getting two real roots here, these two real roots, and d is less than 0, then we are getting imaginary roots. That means there will be no real point of intersection between the line and the ellipse, so the line will lie outside the ellipse. Clear? So if someone wants to ask you about the point of contact, you are it if the another way, if another way, if you write in this manner the equation of tangent, then we can easily find the point of contact. In the previous way I have told about you about the ratio, you need to equal the ratio, and if you equal the ratio, the point of contact will become, let us say this is the tangent, actually this is the tangent, let us say, and this point of P is the point of contact, then P will become plus minus a square m over root a square m square plus b square, and plus minus b square over root a square m square plus b square. Okay, clear? So if someone asks you about the parametric, if someone asks you to write the tangent equation in point form or in parametric form, then how it will look like? So if you want to do you know that equation, if the equation of the ellipse is this, then at point x1 y1 the tangent equation will be x1 over a square plus y1 over b square equals to 1. In parametric form, x1 is replacing with a cos theta and y1 is replacing with p sin theta. Put the same over here, you will get x a cos theta over a square plus y b sin theta over b square equals to 1. That means x by a cos theta plus y by b sin theta equals to 1. That is equation of tangent in parametric form. Clear? Now if we let us start with normal. If you want to see how normal looks like, if this is the tangent, suppose, then this will be the normal. Okay, so equation of the normal will look like at point x1 y1, it will look like a square x over x1 by b square y over y1 equals to a square minus b square. Okay, in this manner, how you are getting this? You know perhaps about the very easy equation is that if we differentiate this, you are getting 2x over a square plus 2y over b square dy over dx equals to 0. It means dy over dx is minus 2x over a square over 2y over b square. At x1 y1 it will be 2x1 over y square and 2y1 over b square. This is the tangent equation. And if we are writing the equation of straight line, that is equation normal is a straight line, and if we are writing the equation of that straight line in point form, that is the y minus y1, m will be just so for slope it will be minus 1 by m. Okay, equals to minus 1 by m x over x1. If we simplify, you will get like this. Clear? And if someone say that write this equation of normal in parametric form, how it will look like? just put x1 in place of x1 a cos theta and in place of y1 b sin theta. If you are putting this, then you are going to get ax sec theta and by cosec theta is equal to a square minus b square. This is the way you are going to find the equation of normal in slope form, in parametric form. So if you want to perform in slope form, it will just look like y equals to mx plus minus m a square minus b square over a square plus m square b square. You need to memorize this part, because if I discuss more on this part, the video will become larger and it may make you bored to see the full video with full energy, right? So this overall part you are going to have in ellipse. Let me discuss some questions, then it will, I think, clear you more. Okay. Let us say equation of the ellipse is like this. Then how can you say that this equation is representing an ellipse? Then what will be the condition for A and the condition for B? Then you know that the condition for A is this part is a square positive, this part is also positive, because you are getting in the lower a square and b square. Then 10 minus a will be greater than 0 and 4 minus a will be also greater than 0, that is a greater than a less than 10. From here you are going to get a less than 4. That means first one is saying that and this is suppose 4, this is 10, a less than 10 and a less than 4, that means a is less than 4, this is the common, a is less than 4, that is a less than 4 will be the condition, so that this equation will be ellipse. Clear? Let us say some new part. It may give you some better idea. You will have to solve many more questions, I know, but let us say another question. The equation of the ellipse is written in like this. Suppose this is the equation of the ellipse and the major axis is y axis. Okay, major axis, given major axis is y axis. Okay, then minor axis will be x axis, and f is a decreasing function. F is a decreasing function. Then what will be the range of a? What will be the range of a? As f is a decreasing function, for decreasing function you know that if x1 less than x2, f of x1 greater than f of x2. We know that as major axis is y axis, this value is bigger, then f of a square minus 5 is bigger than f of 4a. As it is a decreasing function, then a square minus 5 will be less than 4a. That means a square minus 4a minus 5 less than 0. From here you are going to get a minus 5, a plus 1 less than 0. If we know the sign scheme, we have to write here 5, we have to write here minus 1, and just put the plus infinity minus infinity plus minus plus. As it is negative, you are need to take this part only. That means x belongs to open bracket, as it is less than that. If it is equal to, then it will be close bracket. As it is less than, then it will be equals to an open bracket. it will lie open bracket in -1 5. This is the range of x. Clear? I think that these are the small part. Okay, you need to clear, because you need to have many more other questions also, I know. And let us say some about eccentric angle one question. Let us give you the idea. Suppose the question is the equation of the ellipse is given. The eccentric angle, we have to say the eccentric angle at the extremities of latus rectum. The eccentric angle at the extremities of latus rectum. Then you know that the condition coordinates of the latus rectum extremities is plus minus a plus minus b square over a. This can be written for eccentric angle in the parametric form, that is a cos theta b sin theta. This is that means AE you can write a cos theta and plus minus b square over a, you can write b sin theta. From here, if you do the find the value of tan theta, you are going to get so you are going to get actually plus minus, suppose plus minus, you can say b square over a and by plus minus e, that is plus minus b over ae, that is theta is tan inverse of, let us say taking the positive one, this is the eccentric angle, right? Tan inverse b over ae, eccentric angle at the extremities of latus rectum. Please clear it. You need to clear the concept first and then go for solving, right? So some one important tricky question is that, suppose you need to find the length of the common chord of the ellipse. Equation is given like this. This is the equation, and equation of the circle, the length of the common chord of the ellipse and the circle equation is this. You need to find the length of common chord. Then how you will find? As you know, you can write, if you draw, first draw it, how it will look like. The equation of the ellipse, suppose the center is 1 2 and this vertices is 3 0 minus 3 0, okay, and the circle, the equation of the circle, you are going to get x minus alpha whole square plus y minus beta whole square equals to r square, that is radius equals to 1 unit. That means radius 1 unit means, suppose the circle this minus axis also is suppose this is 0 2, this is 0 minus 2, okay. So the circle will look like this short circle, because the radius is 1. So if the circle radius is small, then you can say there is no common chord. If the circle is lying inside the ellipse, then how will you find the common chord? If there is no common chord, then you can say that length of the common chord, nothing is there. Clear? There will be no length of common chord. कॉमन कॉर्ड प्रेजेंट नहीं है, तब लेंथ कैसे प्रेजेंट होगा? क्लियर, राइट? सो this much I have discussed you some problems regarding this. It may help you. Okay, and today I am ending my discussion. I think that these problems are tricky and it would help you actually to uh, solve how to solve this tricky part actually, right? So I hope you have understood the part and you should solve from any of the books, competitive JEE books, and get it clear about the how to approach other type of numericals. Uh, Please note, in most of the question, the slope form of tangent is very much necessary. Slope form of tangent and the slope form of normal. Please note it. Don't make any wrong over there. If you try, if you practice, this form will be memorized easily. You need to memorize and you need to put forward in the exam so that time consumed for that math will be very less. And in WebG you will find that many more questions come from coordinate geometry. So don't be scared about coordinate geometry. Please look more about the part coordinate geometry. Try to practice, and if you practice more, if you learn that clearly, then definitely you are going to get a good result. You will get admitted in Jadavpur University in definitely a very good department, maybe computer science, IT, electronics, electrical, like that. Your rank would be less than 400. Definitely don't be scared. Please try to learn with full confidence. Please try to put your thinking ability over here. If you can think, then everything is easy, right? Thank you. I hope this lecture is small and it would be completed within 50 minutes. Okay, thank you. Let's enjoy. I will be uploading the other lectures also very soon. I will try. Okay, will be updating my channel also. Okay, thank you.